Suppose A is the vector 3, 4. Oh, that's right, we're using round brackets, aren't we? Which I think is wrong, but then I'm at an S. Okay. Suppose I have this vector. First question, what does that mean? Bless you. If I write that, what does it mean?
What do you mean? It means what it says.
The coordinate.
It has 3 on top of 4 in round brackets. What does that mean?
That's your vector, like the 0.34 from.
It's
origin.
not a point.
Okay.
Oh, we're getting somewhere closer.
From the origin 0.
So it's the vector that gets me from the origin to the 0.34. Could you say that another way? How else could you describe that vector?
OA.
How far across did I go?
3,
And how far up did I go, someone other than Ben?
4.
So in other words, it's the vector that goes 3 across and 4 up. I'm going to come back to that. Okay? I want to talk about, I better write it, the unit vector A hat, which is A divided by the length of A. You can put a squiggle under A hat. Some people do. Like, it's not wrong to do that. I tend not to, because once I've got a hat on it, I know it's a vector anyway.
What's the hat mean again?
It means it's a unit vector. What does unit vector mean? 1, right? Unit is 1. If I do this, what's going to be the length of this vector?
1.
Well, let's work it out, alright? A is 3, 4, divided by it. How do I work out the length of 3, 4? Someone who hasn't answered the question yet. I think that's you and you. Pythagoras, right? 3 squared plus 4 squared. So that's, what's the square root of 3 squared plus 4 squared?
Oh, plus 9 plus 16.
5, correct. This is a Pythagorean triad. So it's 1/5 of 3, 4, or if you prefer, it's 3/5, 4/5. Oops, as a vector. You can write it either way, both are fine.
That's not 1.
Not finished yet. It's a vector. What is the length of A hat?
1.
Is it? Don't just randomly call out numbers then. Get your pen and paper and calculate for me, using Pythagoras, the length of this vector. Go.
I bet you like 20
Wait, what's the 1/5 of? What's that?
This is the vector 3, 4.
What's the
1/5 of
1/5
A.
from?
Sorry?
What's the 1/5 from?
It's 5. This is 9 plus 16 is 25, so root 25 is 5
Yeah.
on the bottom of a fraction.
Right.
Dividing by 5 is the same as multiplying by a fifth.
Yeah.
So what is this? Calculate.
1.
And give everyone else a chance to catch up with you. And write it down like I suggested, so you practice.
What does that bottom line say? Not the bottom line, the one right above it. Yeah.
The vector, 3/5, 4/5. This is a scalar multiple of this. I can put the fifth inside, or I can leave it outside. Both of these are perfectly valid. They are the same vector.
Why is
Because the fifth applies to everything inside.
Oh, I just don't see the line. I was confused. Sorry. Okay. The
Okay.
line under 3.
Okay. That better?
Yeah. Thank
Okay.
you.
By the way, Ben, you do have a tech-free exam. Can you do this without a calculator?
Yeah,
Can you show me that you can do it without a calculator?
maybe.
Try.
Is that the formula we should remember?
That's the formula for unit vector. So if I get a vector and divide it by its own length, the result is going to be a vector of length 1. It's going to have length 1. I'm going to define I hat as being the vector 1, 0 and j hat as being the vector 0, 1. Why did I do that? The reason is we don't like doing this, especially when we have 3-dimensional vectors, let alone 10-dimensional vectors. We don't want to write it like that. So instead what we're going to do is do things like this. So for example, A, 3, 4 is 3i hat plus 4j hat. And this,
Are they like constants, or is that like?
yes, this is component form. Another name for it is Cartesian form again. Anything that has a horizontal and vertical is called Cartesian.
Do I need to define that, or is it like?
3 across, 4 up.
Is it universal knowledge that that's?
Absolutely universal. And when we get to 3 dimensions, it's going to be ijk. Everyone who knows about vectors will know what you mean if you use ijk. These vectors have hats. Is the length of this vector 1?
Yes.
What do you think, Julia? How do I work out the length?
1 cross 0. Oh. 1, yeah.
Yep. Okay. So these vectors have length 1. So this has length 1. That now has length 3 across. This one has length 4 up. And I'm back where I started. So this turns out to be a much easier way to work with vectors because I can do all kinds of things I'm very used to, which we're about to practice. I can collect like terms, I can expand brackets, things like that. And I can do normal algebra with a vector instead of worrying about what it means here. So I'm looking for. So for example, so you already know how to find the length of this vector, right? Right? If A, let's go, if B is 7i minus 12j, then what's the length of B? Go. And you just go square root, horizontal, vertical, keep going. Practice the setting out then. You have to be able to do this tech-free. Practice doing it tech-free.
Okay, well, I can't take the square root of that without it.
Yes, you can. 169. You haven't seen that one before?
I have seen that one before, but I didn't get 169.
Oh. Should be 7, 12, 13. 49 plus 144. Oh.
That's 193.
What have I done wrong? Oh, it should be 5, 12, 13. That's what I did wrong. Okay. So it is a disgusting number then. What do you do if it's tech-free and it's a disgusting number?
You leave it. Or you simplify if you can.
Can you?
No.
I don't think you can either. So this is a perfectly good answer. And then this is far preferable to a decimal answer. Far preferable. Don't just automatically reach for the calculator. Okay, my mistake, I should have said 5, 12. Anyway, doesn't matter. I can scalar multiple, like we did. 3 lots of 2i plus 7, oh, you can't do 3 times 17 in your head, can you? 5j, and you just go 6i hat, 15j hat. algebra exactly like you're used to. And the length of this one will be 3 times the length of this one.
What's the point of the I and the j if they just equal 1?
They also give you direction. Remember, they're vectors.
Right.
Their length is 1, their magnitude is 1, but they also tell you direction, which allows me to do clever things like this. In one step, I can do 2 or 3 operations, which is what's going to happen. I can add vectors. So I can go, I don't think I need to convince you of that, do I? Let's just, I'm just going to make some up. I hat minus 5j hat plus negative 2i hat plus 3j hat. This vector plus that vector. Well, in the resulting vector, how far across did I go? 1 minus 2. And how far up did I go? Negative 5 plus 3. Effectively, all I've done is collect like terms. It's normal algebra, just with hats instead. Sounds like something that should be a trend. Doing algebra with hats. You can subtract just as easily. Let's do the same 2 vectors. Minus negative 2i plus 3j. It's getting messy. Have a go. Off you go. Be careful with your negative signs. So, equality. When we did equality for vectors as arrows, we said they had to have the same magnitude and the same direction, same length, same pointing direction. When we're doing equality in component form, we can just treat it like algebra. The I hat component has to be the same, and the j hat component has to be the same. Each I can't spell, component must be equal. So, for example, e.g., you might get a question like, calculate m and n if 7i minus 5j equals 3m plus 1i plus, 4n minus 9j. And Ray's going, this is exactly like the same things we did with matrices.
Yeah.
Because effectively, remember, this is a matrix. How do I solve that? Well, if they're equal, then this component must be the same and this component must be the same. Therefore, 7 must be 3m plus 1. 3m is 6, m is 2, and negative 5 must equal 4n minus 9. N must equal 4, n must equal 1. If C is 3i minus 6j, oops, that was meant to be I hat, calculate C hat. And you can put the square line if you want to, it's up to you.
The same I was saying.
They do a bit, don't they? That one's a C, and that one's an I. Is that better?
Mm-hmm.
Good. Off you go, calculate C hat. Check free. No, Ben, I think it was you, we were talking about the negatives and the squares. I know it's going to be positive, so I just ignored it when I'm doing negatives. Otherwise, I'll just confuse myself. 3I hat, oh, well, it could look like a C. I hat minus 6, J hat all over 9 and 36. It's 45. That's 9 times 5. Do I agree with them? Yes, I do. Is this? I've got a vector C. Now, determine vector D, which is in the same direction as C, but has length 3. So I got my C, which was 3 across and 3 across and 5 and 6 down. It's got a long length. Its length is 3 root 5, so about 6 point something. And I want another vector in the same direction, but whose length is exactly 3. And I do that by going via C hat. Because C hat is in the same direction and has length exactly 1. I know that. That's the definition of a unit vector. So D is just 3 lots of C hat. So I can get a vector in the same direction, but at whatever length I happen to need it to be. Which we're going to use later. So that becomes 3 on root 5 I hat minus 2j hat. So that's one of the things we use unit vectors for. Essentially, we're getting a vector that only tells me direction and tells me nothing about length, just says the length is 1. And I can use that to make another vector in whatever direction I need. I'll give you one more thing about this is, you can work all that out, was this. How do I know whether two vectors are parallel? How do I know whether two vectors are parallel? Yes, Ben?
They're the same factors, or they have like the same.
Again, I think I have the right idea. Wrong. How do I get words that are useful?
I forgot the word. They're like they can go into each other.
A is parallel to B if and only if A is some scalar multiple of B.
Yeah, that's what I was trying to say.
Where K is a real number. if they are a scalar multiple of each other. For example, I hat, I'll use their example, doesn't really matter. I hat minus 3j hat, and it doesn't matter what you do, does it? 3I hat minus 9j hat. These two vectors are parallel, because this one is 3 times that one. Be careful. Are these two vectors parallel?
No. Yes.
What do you think?
Yes.
Because people disagree about this.
They're parallel, but they're just
Opposite direction.
yeah.
So some people say this is anti-parallel, meaning parallel but opposite direction. But if in general you say whether they're parallel, are scalar multiple, these are a scalar multiple of each other, just a negative scalar multiple. So they are technically parallel. Some people disagree with that. But yeah, you're just looking, is there a scalar multiple of one that gets me to the other? Might not be a whole number, could be negative a quarter, it's still a scalar multiple.